Unlock your potential today at skillbakery.com.
Hello and welcome to another exciting video. In this one, we'll be talking about traits in Rust. Traits are a way to define shared behavior between types. A trait can be thought of as a collection of methods that can be implemented by different types. If a type implements a trait, it guarantees that the type has the behavior described by that trait. Traits are similar to interfaces in other programming languages like Java or TypeScript, where you define a set of methods that types need to implement. Key points about traits are: traits define methods that can be shared across types. A type must implement a trait to gain the behavior defined by it. Traits allow for polymorphism, enabling us to write generic functions that can work with any type that implements a specific trait. So let's start with a simple example. We have defined a trait and we're calling this trait as describable. Now this contains a method signature called describe and it's returning a string. So this method signature needs to be implemented, and in order to implement it, we have defined a person struct. Now, once the person struct has been defined, we are implementing this describable trait for the person struct. So here you can see that we are implementing the describe method. Now the describe method is printing this output which says the name and age attributes, and down below we have our main method. So in the main method you can see that we are instantiating the person object, and the name is provided as Alice, age is provided as 30, and then we are calling the describe method on the person object. So this is the trait that we have defined in our describable. Now as you can see, we have two files over here. Inside the src directory we have main.rs, and within that I've created this bin directory, and inside that we have this trait.rs file. So here, in case you have more than one rs files and you are making use of cargo run to execute it, by default cargo run will always execute the main.rs file. So here you can define other files inside a binary and you can give them the command cargo run and specify that the binary that you want to run. And here you don't have to specify the extension .rs, you just have to specify the name of the file. So this way, if the trait.rs file is not a module, then you can independently execute it. If it's kind of a module, then we will have to include it in our main.rs file, and from there the cargo run will execute it. So the other approach will be discussing in the upcoming lectures, but for now let's go ahead and execute this file cargo run when trait. So here you will notice that we have this Alice is 30 years old. So this is the simple example that we have. Now let's go ahead and try implementing traits for multiple types. So we'll take the same describable trait, and here along with the person we will also include another struct called car. So here we have two structs now, person and car, and we'll be using the same describe trait for person as well as for car. So we have already defined it for person. Let's go ahead and implement it for car as well. So here we have the implementation for car. This car is, and here we have make and model. So these are the two attributes for the car struct. Now inside the main method we will simply go ahead and make use of the car instance, and then we can make use of the println command to print the output over here. So we have person.describe and now we have car.describe over here. Now if I run this, you'll notice that we have Alice is 30-year-old, and then we have this car is a Toyota Corolla. So we have the make and model being displayed as a trait for car object. We can use traits in generic functions to allow multiple types that implement the same trait. This enables you to write generic code that works across different types. We'll be again going ahead with the same describable trait and we have already implemented it for person in car. Let's make it generic. So here, what we'll do is we'll create a function that can take any type that implements the describable trait. So here, let's create that function, and the function is print description, and it's taking a type which can be of type describable, and here we have the item. Now we are using the item.describe method on that to print it. Let's go ahead and create one more struct, and with person car we also have now a book struct. Now for book, what we'll do is, again, we'll have to implement it. So the method that we will be implementing over here after the car is the describe method, and here we are saying that print the title and author of the book. Now that we have done it, what we can do is just go and make use of a book instance. So after car, we'll be creating another instance, and for book instance, we have the book object now, and for book instance, we can just go ahead and make use of the print description method directly. So here we have print description, and you'll notice that we're passing the book object over here. Now let's save this and do a cargo run, and here you can see we have the LS is 30 years old, this car is a Toyota Corolla, and finally we have this Rust programming by Steve Klapnick. Now if I just go ahead and do another print description, and this time around I pass this person, you'll notice that I'm not providing the method or the trait that it needs to execute on. That is already taken care by the print description method. And here, when I go ahead and do a cargo run, again, the print description is printing the same description that we had over here using the describe method. So what we have done is we defined a generic function called print description, and it kind of accepts any type as long as that type implements the describable trait. And in our main function, we have created the instance of the book struct that implements describable, and we call the print description method. Now, traits also have default methods. For example, a trait can also provide a default implementation for some methods. This way, types can use the default behavior without having to implement the method themselves, but they can still override the behavior if needed. For example, we can have a trait called greet. So let's go ahead and have another trait over here. After describable, we have this trait, and you can see that the default implementation of this trait is a function called hello, and it says hello. But the structs that will be implementing the greet trait can obviously go ahead and override this. For example, if I implement it for person over here, like implement greet for person, and here I'm not overriding the hello method, I'm just leaving it as is. Now if I go ahead and make use of the person.hello, you'll notice that it is going to give me the same output. So here after the print, we'll have the person.hello. Let's save this and run it over here using cargo run when trait command. And you can see that the default method is called and it prints hello. So to summarize, traits are like interfaces in Rust, allowing you to define methods that different types can implement. You can use the IMPL keyword to implement traits for types. Traits enable polymorphism in Rust, allowing you to write generic code that works for multiple types that share behavior. Again, provide default method implementation in traits, which types can either use or override. Traits work with generic functions, allowing flexible and reusable code. So we can say that traits in Rust provide a powerful way to define shared behavior across types, and by using traits, you can write clean, reusable, and flexible code that can be applied to many different types. If you find the video helpful, don't forget to like and subscribe.